Hello, Math 2 Extended. This is Unit 3, Lesson 2, More Factoring. So last time we worked on factoring trinomials and looking for common factors that were monomials. Today we're just going to continue working with factoring. So last time what we talked about, I just want to do one example of that. Last time what we talked about is looking at your trinomial or your binomial and thinking about those terms and what they have in common. And sometimes the answer is that they don't really have anything in common or just a 1, but sometimes they have some factor in common. And in this case, the factor that they have in common is a 2. And we want to factor that common factor out. Or unmultiply it, and so it goes at the front of the expression now, and we think about unmultiplying that 2 from each of these terms. So we have x squared plus 6x plus 8. And so the process of factoring is a process of unmultiplying. So I just unmultiplied that 2. So now I'm showing it, instead of as 2x squared plus 12x plus 16, I'm showing that it's 2 times x squared plus 6x plus 8. Especially if you have a trinomial here, you want to keep trying to factor that. We've got a power 2 here. We can further break that down into 2 binomials. And so we're really just thinking about this part of it now to break it into the 2 binomials. And our lead term here is an x. So we're going to have x's in each of our 2 binomials. And over on the end, we have an 8. And 8 is 1 times 8, 2 times 4. We're trying to get a middle term of 6. So our combo that we want to use is 2 and 4, both in this case positive. So this is our complete factorization of 2x squared plus 12x plus 16. Now make sure you don't lose the 2. It shouldn't disappear. If the 2 disappears, then it's not equal to the original expression. So if we ended up with that 2 gone, it's not equal to 2x squared plus 12x plus 16. So you do want to make sure you have that 2 there. You don't want it to disappear. What if, though, there isn't a monomial factor, or there isn't a common factor that they all share? Well, in that case, I can't factor a 3 out because 7 is not divisible by 3 and 2 is not divisible by 3. And we do want to stay in the world of integers when we're factoring. So if it's the case that there is not a common factor, what happens is we have to just keep that 3 with one of our x's. So the way that you can get a 3x squared as the product of these 2 leading terms is that one of them is going to have a 3 with it. So this is a 3x times an x. That's the 3x squared right there in the product. So that 3 right there, it doesn't just affect the leading term, though. That 3 is going to be distributing to here and to here. So whatever number goes over here on this far side is also going to be multiplied by 3. So we have a 2 as our constant in this trinomial. So we've got a 2 over here at the end. And the only way to get a 2 is a 1 times 2. And I'm going to write this out. So we kind of have 2 possibilities, and they are different. We could have the 2 here and the 1 here, or we could have the 1 here and the 2 here. And because one of those binomials has a 3 and the other one does not, those are different things. And so, especially at first when you're doing these, sometimes writing the possibilities out is a good thing, so you can kind of see them at once. And then either in your head or on your paper, multiply out those middle terms and see what you get. In that first top factorization, our middle term is a 2x and a 3x. So those could add up to at most 5. That is not going to give me this 7x that I need. So I know this one can't be right because it can't give me a 7x. But on the bottom one, I have a 1x, and remember the 3 multiplies the 2, so that's a 6x right there. And the 6x and the 1x can or add together to give me that middle term of 7x. So they just need to both be positive. So our factorization is 3x plus 1 and x plus 2. And just like before, it is okay if the order of those two factors is different. Like we could write it this way, that would be fine. But the 2 needs to be with the x with the coefficient 1, and the 1 needs to be with the x that has the coefficient of 3. So it does need to be those two factors. The order of them is fine either way, though. Okay, we just did that one. It came up twice, but who knows? All right, so example 2, 12x squared plus 17x minus 7. So I have on your paper and on my screen here, I have 6 combos because unfortunately a 12 at the beginning here has loads of different possibilities. So a 12 could be a 1 times 12, it could be a 2 times 6, or it could be a 3 times 4. And it's a little difficult at first to know which one it should be, and sometimes your first guess is not correct. So I'm going to fill these in, and I'm going to duplicate them over here so that I can write out all of the different combos. And again, I wouldn't necessarily, we won't always be writing out all of these combos, but at least at first, I think it helps to kind of see what it could be. So we've got 12x squared at the beginning, and so we have each of those coefficients. I didn't even write my x's. How silly is that? So we've got 2x and 6x, or 3x and 4x. All of these would times together to give us 12x. And then on the constant end of this, we have a negative 7. So the only way to get a 7 is a 1 times 7. So I could have a 1 and a 7 like this, or I could have the 7 with the 1x and a 1 with the 12x. And I could have a 1 and a 7 here, or it could be 7 and 1. So I'm writing out all 12 possible combinations of terms. So now we're going to think about what middle each of us gives. That's a 12x and a 7x. So we could get a 5 with subtraction here. We have a 6x and a 14x. So we could get something like an 8x, but we're looking for a 17. Here I have a 4x and a 21x. And that is our combo right there. If we have a positive 21 and a negative 4, that's going to give us what we want. So we want the 7 to be a plus 7 so that when it multiplies by 3, we get 21x. And we want the 1 to be negative so that we have that minus 4x. So we found our combo, and that is the correct factorization. But sometimes you don't find it on the first try or the second try or even the third try. Sometimes you have to write out more combos or think through more combos, maybe if you're not writing them out formally. I'm just going to finish writing out these middles so you can see all the possibilities. So not every trinomial is factorable. In this unit, we'll give you factorable ones. Did I write that the same? I did write that one the same. I need to switch it. Let's see. That would be a 7 and a 1. So that would be a 28 and a 3. So you can see there's only certain combos that I can have with these, with the 12x squared and the 7 at the end. So when you start doing this, it's a little tricky. You try something. If it didn't work, try another combo until you find the right combo. All right, we have two problems here. They both start with the 3x squared. They both end with an 8. One of the 8's is positive and one of the 8's is negative. So our factors, that 3 is not a common factor, so we're going to have a 3 with one of our x's. 8 is 1 times 8 or 2 times 4. I'm going to start with 2 times 4 and see what I can get from that. And you might not know which number to put where. Try something, and you maybe can write it down and kind of mentally think about the middle term. I've got a 4x and a 6x, and that could give me a 10. Ooh, so maybe that'll be good in a minute, but that didn't quite work. So then just erase and try switching it. So I'm going to put the 2 here and the 4 here, and then you'll kind of check and think about the middle and decide if it's right or not. In this case, we can get a 14. So if they're both negative, that adds up to negative 14. And then a good idea is to just check to make sure the sign of that end number is correct. And we have a negative 2 times a negative 4. So that is a positive 8. So kind of do a mental check or a written check of your factors to make sure that they are correct. So that's 3x minus 2 and x minus 4. So on this one, I'm going to try the 2 and the 4 again. This gives me a 2x, and this gives me a 12x. And that can give me this 10 that's in the middle if the 12x is positive and the 2x is negative. Always kind of double check. We've got a negative 2 and a positive 4. That does multiply to negative 8. So I have the sign right for the end number as well. So it looks like these are our 2 factors. And you can formally check your factors to see if they're correct, or you can sort of informally just check it in your mind. Okay, here's a couple more. 2x squared plus 9x minus 5. That 2x, or that 2 is going to stick with one of the x's. If you want, you could write out sort of both ways, 5, 1, 1, 5, and see if you can figure it out from there. Or you can just write one of them, and if it's not right, erase. So we can see that the best way to get a 9x is going to be the second one. That's going to be a 2x. Let's see, we want that to be a plus 5. So this will be a minus 1. That's going to give me a positive 10x and a negative 1. So 2x minus 1 and x plus 5. Okay, 3x squared minus 2x minus 5. We're going to have the 3 with one of the x's there. Trying to get a 2. So I think if we have a 5 and a 1 that we're using, because that's the only choice. So if we multiply the 5 over here, that's going to give me a 15, and that's going to be too big to get a middle term of 2. So I think we're going to have to put the 1 here. So let's just kind of do a quick little visual of this. We've got a 5x and a 3x. So we want to get a negative 2 middle term. So this is a negative 5 and a positive 3. So minus with the 5, plus with the 1. And that's it. We've got our factorization. Okay, 3x minus 5x plus 1. Okay, when there's a coefficient present, so we've now talked about 2 cases where there's a coefficient on the leading term. We've talked about the case where it's a monomial factor, and we've talked about the case where the 2 has to stick with one of the x's. So anytime you're approaching a problem that has a coefficient in front of the x squared, take a second to check for a common factor, and then only keep the coefficient with an x if you have been able to, or you haven't been able to find a common factor. So in this first one, if I think about that 2 and whether or not it's a common factor, you notice right away that we've got an 11 in the middle. So this one is not a common factor. So that means the 2 has to stick with one of the x's. I'm going to come back and finish that one in a second. If we look at the coefficients of the terms over here, you can see that they are all even, so we can factor out a 2. If you're able to factor out a common factor, do that first, and then try to factor into 2 binomials. Don't try to go straight from here to here. You will most likely not be successful. I have not had very many students that can do that successfully. it doesn't take that long to write out this step, and it will make it so much easier for you if you do. So let's go back to the first one and finish it up. So we know we have a 2 with one of the x's. We have a 40. So there's a couple possibilities here. 2 times 20, 4 times 10, and 5 times 8. We need to get an 11 as our middle term. And remember, when you look at this list, whichever one we put right here is going to get doubled. So kind of thinking about it that way can help you. So one of these numbers in this list is going to be multiplied by 2. So it looks to me like it's going to be this last one. Because if we multiply the 8 by 2, that gives me 16 and 5. So I want to multiply the 8 by 2, so I put it over here so that the 2 will distribute to it. That means the 5 goes here, and I am going to just kind of formally check. I don't know why the 8's pink, but it's bugging me. Just going to formally check to make sure that that's right and to think about my signs. I've got a 5 and a 16. To get a negative 11, I want the negative on the 8 and the positive on the 5. And that is our factorization of 2x squared minus 11x minus 40. This second type, the type with the common factor, monomial common factor, that is, I think, an easier type. You can get that common factor, in this case 2, out of there, and then you've got some smaller numbers to deal with. So we're not dealing with 40 anymore. We're just dealing with 20. 1 times 20, 2 times 10, 4 times 5. So we have less combinations and easier numbers to think about. We're trying to get an 8, so it looks like we're going to use this combo right here. So we're going to use a 2 and a 10. Our 8 is negative, so that's going to be a negative 10 and a positive 2, and there is our factorization. So the coefficient could end up being a number in front like this, or it could be mixed in with the x, and it just depends on the other terms and whether or not you can factor it out or not. Okay, we'll try these two. Always look for a common factor. You can see all of these have an x, so they're also all even numbers, so I'm going to factor out a 2x. That leaves me with 11x squared plus 2x minus 9. The 2x is going to stay. It doesn't disappear or go away. It's hanging out. The 11 is with one of our x's. And our ending number is a 9, so that's either 1 times 9 or 3 times 3. I think the 3 is not going to work because that's going to give us a 33 and a 3, and that's not going to help us get a 2. So we're going to try the 9 and the 1. And, it's good to think about where you're putting things, but if you have a hard time thinking about it, throw them in, test it. If it's wrong, switch it. I think we want the 9 here. So that gives me a 9x and an 11x. And that definitely can give me that positive 2 if the 9 is negative. So it's 11x minus 9x plus 1. And then don't forget we've got that common factor of 2x at the very front. Okay, 3x squared plus x minus 10. Remember, this middle term is a 1x. The 1 is not written, but you've got to remember that it's there. And 3 definitely can't divide these terms, so we're going to have the 3 with one of the x's. 10 is either 1 times 10 or 2 times 5. Let's try 2 and 5. I'll just throw them in there and see what I get. 2x and 15x. So it's not right. So I'm going to go back and erase and switch them and try again. Let's put the 5 in this factor and the 2 in this factor. Here's a 5x, and there it is, a 6x. So that can definitely add up to 1. I just need to subtract the 5x. So we'll put a negative with the 5 and a positive with the 2. And that is a negative 10 at the end because the 10 comes from multiplying this negative 5 by this positive 2. So we got the right factorization. So if you want to think carefully about where to put your numbers, you can. If you don't want to think about where you're putting them, throw them in there, test it. If it's wrong, erase and try again. All right, last little kind of side topic. Remember what happens when we multiply conjugates. So multiply these two pairs together and just remind yourself what happens. Now, conjugate, if you've forgotten what that means, it means the two things are the same except with opposite signs. So we've got 4 minus 9i and 4 plus 9i, 4x minus 9 and 4x plus 9. So the product of this first one is 16 plus 36i minus 36i minus 81i squared. And with conjugates, the middle cancels out. And in this case, with imaginary numbers, this negative 81i squared becomes a positive 81. So we've got 97 as our answer. With polynomial conjugates, it's kind of similar. 16x squared plus 36x minus 36x and then minus 81. Again, we have that middle term canceling out because it's conjugates being multiplied together. In this case, we can't combine those last two terms, and our answer is 16x squared minus 81. So when we multiply conjugates together, we end up with a zero cancellation in the middle. So we're going to work on factoring something called a difference of squares. So these numbers you see here are all perfect square numbers. 49 is 7 squared, 4 is 2 squared, 25 is 5 squared, 81 is 9 squared, 9 squared is 3, or 9 is 3 squared. These are all the difference of two squares. So when you're trying to factor the difference of two squares, the two factors are going to be conjugates. And that's what causes the fact that they're conjugates, they have those two different signs, that causes that zero middle term to happen because we have a cancellation. So x squared minus 9 is x plus 3 and x minus 3. And you did try some of these on your first assignment as well. None of the ones on the first assignment had a coefficient though. So 81x squared minus 25, those are all perfect squares. So our two factors are going to be the same. One's going to be a plus and the other one's going to be a minus. So there's our factorization. And always remember, you can multiply it out if you want to, or if you think you're wrong. We've got 45x and negative 45x and then minus 25. So it did work. The factorization is correct. Okay, this last one on the end, a little different than the other two because it has a third power. That is a common factor. They both have a common factor of x. So we're going to factor that x out first, and then we're going to try to factor the quadratic, the squared expression. So perfect square 4 is going to split as a 2x times a 2x. That 49 is a 7 times 7. And we just need the plus and the minus for the conjugates to get that zero middle term. Okay, there are 3 more on the slide here. This is the end. I'm going to write up a factorization so you can test yours out and see if you want to try it on your own and see if you're right. For this first one, factor out an x, and then it'll be an x plus 6 and an x minus 6. Please note the x at the front did not disappear. It's still hanging out. Let's see here. We've got a 25 in the lead, so that's a 5 and a 5. We've got a 64 in the tail. That's an 8 and an 8, and that's a plus and a minus. And then finally, we've got a 9x squared and a minus 1. That's going to be a 3x and a 3x, 1 and negative 1. So those are our factorizations. So thanks for watching the video. If you have questions, let me know. Factoring is a little tricky. These ones that we did today are kind of hard. With practice, though, you're going to get really good at it. So let me know if you need any help. Thank you.